Right, welcome everyone to AWS Summit Online this beautiful spring day. My name is Udi Hershkovich, and I'm the Business Development Manager for Amazon Kendra, our intelligence search service. With me today is Dr. James Kinross of the Imperial College of London, and together we're going to talk about how we can accelerate COVID-19 insights for clinical use with intelligent search. In order to start, we'll talk about what intelligent search is all about, and I'll kick this off by introducing a key problem that our customers have repeatedly come to us with over the years. Regardless of the use case or the business line or even the search technology, customers have come to us over years telling us that search is a problem, mainly search accuracy. People cannot find the information they need very often. And when they do, they still spend a lot of time searching for it, manually reading through documents when they get their search results, regardless of the search technology that we're using. When we started looking deeper into it, what we found was that most of the content people search through today is actually unstructured content. These are narrative stories like website content, documents, research papers, wikis, blogs, and so on. There's a very rich content in there. But at the same time, the tools that people are using to search through that rich contextual narrative are old guard keyword search engines. These search engines extract entities and key phrases from text and leaving all that rich context behind, indexing them for people to basically run keyword search algorithms. As a result, there's a lot of manual tuning for relevance that needs to happen. And in a world of unstructured data, we realized that this is no longer a viable option. So we thought, as we do at AWS, this is a great opportunity to reinvent an experience, the search experience, and this could be extremely impactful across many industries and use cases, reducing manufacturing times for products to market, accelerating research, improving regulatory compliance. There's lots of opportunity there because at the end of the day, search is all about accessing information and getting data to drive data-driven decisions. And so our approach was to look at the tools, the right tools to reinvent the search experience. We almost immediately went to look at machine learning models because they provide the best framework for predicting outcomes. And when you think about search as a problem for a particular input, which is the search query, any number of possibilities, you want to get to the absolute best outcome using neural networks, going through all the different permutations and options down to one or a few best answers for any given query. So this is kind of how Amazon Kendra was born as a AI or artificial intelligence service, part of our machine learning stack, rather than as a data and analytics service, which is commonly associated with search services like Amazon Elasticsearch service or Amazon Cloud Search. So Kendra is an artificial intelligence search service that is powered by multiple machine learning models. It's pre-trained, which is why it's part of our AI services stack at the top of the machine learning stack. What that means is essentially it's ready for you to use out of the box. There's no machine learning knowledge or expertise needed to start using Kendra. Now, if we double click on that a little bit and understand what's under the hood here, Kendra is addressing several problems, mainly search accuracy, and as well as the challenges of setup in a world of data silos and disjointed information. And I'll walk you through one by one what we actually did in the process of actually making Kendra what it is today. The first thing we wanted to focus on is accuracy. And there we realized that the use of natural language queries could provide that rich contextual reference that is missing from keyword search engines. Natural language queries are not just more intuitive, but they allow you to increase the payload of the query to an extent that includes It includes concepts. You can focus on, what am I looking for? Am I looking for a person, a location, a quantity of something, a timeline, and so on. It adds entities. So what is the concept referring to? And in what semantic context? So there's a lot of more richer information in the query itself. And if you start breaking it down using natural language understanding, you can hone in on far more accurate data within documents and other types of content. The next thing that we found was that there's not a single machine learning model that always provides the best answers for every use case. So Kendra, under the hood, uses natural language understanding to break down the text and understand the user query, and then uses multiple machine learning models to find and extract different kinds of answers. The first one being reading comprehension, that identifies those concepts. If I'm looking for a person, let's go find a person and find and extract the name of the person that I was asking about, and so on. FAQ matching allows you to surface curated content. So if you have curated answers to questions that people commonly ask, whether it's employees or customers, you're able to structure them and index them separately in Kendra, and Kendra will try to match the best way through these models the user query with the questions and answers that have been indexed for that purpose. And finally, document ranking. Document ranking is another machine learning model that returns a very similar list of links to documents like you're used to with keyword search engines, but with a much higher level of relevancy. You will find that in the top 5 or top 10 list of documents, many more documents, and probably much, much higher up, are going to be more relevant to what you were actually looking for because of the use of natural language understanding to decipher the intent or the goal, as well as the model itself, which is more accurate than keyword matching algorithms. Two more aspects to this, which were kind of interesting. One is we wanted to make Kendra relevant to many different industries and use cases, and so it's pre-trained on a broad domain of technical content. So you can ask highly technical questions in life sciences, healthcare, financial services, travel and hospitality, and more, and get accurate answers. And the other thing is that because we use machine learning models to execute search, not just to extract entities or identify elements of text, but to actually execute the search, feedback from users about what's accurate and what's not actually is used in order to incrementally learn and improve those models over time. So that's a nice positive side effect of using machine learning in order to execute search. Two other small things, but very important. One is the fact that most of the information is scattered across the enterprise. It may be in public domain repositories, in highly secure repositories, sometimes in file systems on-prem, and in various content management systems in the cloud. We've designed Kendra so that it would reach out to wherever the content is and would not require to transfer content, to store content, and all these cumbersome processes, but basically point and shoot with native and partner connectors so Kendra can extract the content, take the text out of it, splice and dice it, index it in the right way, and then tell you, I'm ready for you to search. And of course, a lot of this content is enterprise content. We assume that it's highly sensitive, no matter what the use case is. So Kendra is designed with several layers of security. Everything is encrypted in motion and in rest. And we apply the ability to run secure search. So different users actually get different search results based on their access and privileges to different documents. So that's, in a nutshell, how Kendra was structured. And where we see our customers actually use Kendra or intelligent search with Kendra is across 5 main use cases. First one is accelerating research and development. We see various companies and organizations in healthcare, life sciences, and financial services are using Kendra to access information, either public research or development and engineering documentation, to speed up time to market for their products. We see companies using intelligent search in reducing regulatory non-compliance risks. We have a lot of customers that are focusing using intelligent search to expand access to information by customers so they can boost contact center intelligence and efficiency and make sure that people, their customers, spend less time searching for information, more time doing other things, and support agents as well can resolve issues faster and more accurately to the satisfaction of their customers. Customer experiences and employee productivity are two obvious outcomes of using a more accurate search with intelligent search, internet-like search experience. When you have an expectation that you can ask questions and get direct answers, why wouldn't it be applicable in the enterprise or in research or in any other field? And so we see organizations like the Wall Street Journal integrate intelligent search into applications and increase customer retention and engagement through those applications and websites. And finally, of course, every line of business, every content owner across the enterprise, as we did at Amazon, is looking to enhance employees' access to information so they spend less time searching for information they need to do their jobs and more time being productive and less frustrated at the same time. So to summarize all this, we are moving from traditional keyword search to intelligent search powered by machine learning, where machine learning is used to execute the search because the world around us has changed. We live in a world of unstructured content. And I think to demonstrate this in a very meaningful way, I'm delighted to have Dr. James Kinross from the Imperial College of London, as I mentioned, join us today and present the tools that they developed to battle the COVID-19 infodemic. James, over to you.
Thanks, Udi, for such a generous introduction. My name is James Kinross. I'm a senior lecturer in surgery at Imperial College in London, and it's a real thrill to be speaking to you today about our work with Kendra and on intelligent search. Now, you may ask, why is a surgeon speaking to you about Kendra? And that's a good reason, a good question, I should say. And there is a good answer for it. When the COVID-19 pandemic hit London in March in 2020, the surgical community was faced with a major problem. How do we keep our people safe, and how do we operate safely, and how do we change our clinical practice to operate under completely unprecedented circumstances? And this was a huge global challenge. It wasn't just a challenge for us in London. I come from an academic organisation and we're a research institute, and we were charged with solving some of the major challenges that we were facing. And we found that the research community really wasn't equipped for solving some of these problems in the speed that was needed. And so we set up PanSurge, and PanSurge was a project really with three goals. The first was to educate. The second was to measure what was happening to us, to try and understand what was happening so we could create new solutions and problems. And the third really was to innovate. How do we create new technologies, new solutions to help us manage this crisis? Now, the first use case that we really came to quite quickly was the infodemic use case. And this is where Kendra comes in. So, of course, the infodemic is not just a COVID-19 problem. It's a global problem for lots of other important health-related problems. But in COVID-19, it really has been a huge problem. So I think just to put that into context, it's a good problem. If you think about vaccine development, this is really an extraordinary and historical achievement. It's only been possible because science has been able to move so quickly. But a byproduct of that is the enormous production of information. So if you look at the number of structured academic outputs between December 2019 and August 2020, it's been absolutely enormous. Well over 100,000 publications in that time frame. And that's not just scientific papers, it's policy documents, data sets, etc. And that's just structured data. It's not even unstructured data. There's been a lot of intelligent analysis of COVID-19, but a lot of other unintelligent analysis on COVID-19. So these data sets create three fundamental problems. The first is, how do we find those little snippets of gold that lead us to new treatments and to new therapies in all of that noise? The second problem is, how do we synthesize that information into relevant clinical evidence that our healthcare workers can apply in the treatment of patients who've got COVID-19. And the third challenge is, how do we ensure the veracity of that information and stop the spread of misinformation that is potentially causing harm, particularly around public healthcare messages. And we've seen a lot of controversy in COVID-19, particularly around the use of masks and now vaccines. So we created Redasa. Redasa is real-time data synthesis and analysis. And it's an attempt to do what some other groups around the world are doing, which is to create a living systematic review of evidence. Instead of having to manually curate information and search for information by hand and then turn that into guidance, can we do that in a machine-driven way? But also it's an attempt to solve the problem of fact-checking. Can we sift through unstructured data and help provide a ground truth which policymakers as well as healthcare providers and the public can use to inform their decisions that they make around COVID? So we've got three components to Redasa. The first is the creation of a continuously and autonomously updating biomedical data lake. The second is a global peer review methodology for curating that data set and using Kendra to help us do that in a really efficient and intelligent way. And then the third part of this puzzle is, how do we use that information in an intelligent way to help solve some of those fundamental problems that I've outlined, for example, autonomous data reporting. Now, we were really lucky to be introduced to Amazon in the beginning of this crisis, and Matt Howard and his colleagues introduced us to some amazing partners, and I just have to credit them because none of this work would have been possible without them, particularly Mirrorweb and Amorphic. And Mirrorweb brought with them their technology to help us solve the first major hurdle that we had to overcome. And that was dynamic web crawl. So our strategy was to target producers of data that we knew to be high quality and relevant, and to ingest that into a data cloud. And because data was being produced so quickly, that had to be very, very targeted, very, very precise, but also comprehensive. And Mirrorweb's technology allowed us to do that. So we set that web crawl technology to target publicly available data sets that we knew were going to be important, but also a series of unstructured data sets that we thought that would have value. Now, these might be guidance and policy documents, or it might be even more grey literature, so news articles, for example, or indeed social literature, social data. You can see the pipeline in that illustration on the slide and how it was created. But effectively, the crawl server pulls down that data into an Amazon S3 bucket, which is then stored within the Amorphic platform. And then our academics and our scientific researchers were then able to access that data. The immediate challenge we then had was, well, okay, what do we do with that data? So having it's one thing, meaningfully interpreting it and using it is an entirely different challenge. And actually, we then had a different search problem. And what we wanted to be able to do was to precisely draw down data to help us answer very specific healthcare questions in a really targeted way. And this really was where Kendra came in and transformed what we were trying to do. So you can see in that pipeline of data before you, you start with unlabeled documents, either in unstructured or structured formats, which are then incorporated into a pre-labeling and processing step. And you can see Kendra there is really integral into that. One of the beauties of working with AWS is, of course, we were able to leverage their stack of machine learning technologies, and actually it made us incredibly efficient. So we were then able to pull that data down into SageMaker as part of its labeling process. And you can see on the left-hand side there part of our early labeling methodology, which in fact used SageMaker so that we could then hand annotate key components of that search, which could then be finally pulled down into labeling domains based on 4 predominant columns. So relevance, mesh term tags, quality, and data type. Now, in practice, using this information in a more meaningful way requires a community of scientists and clinicians who have expertise to be able to use this information in a specific way. So we then went about setting up a community. And for us, we've adopted a human-in-the-loop methodology. Having information is one thing. Having a community of people that need or are able to access and do something proactive with that data is entirely different. And we think a human-in-the-loop methodology is a critical way of achieving that goal. So what we then do is we then ask our community of data labelers questions. So, for example, what is the time interval between SARS-CoV-2 infection and testing positive in March and April? That was a really important question. Kendra is able to provide that segregated document to those individual curators or communities of curators who can then quality assure those data. So they can say, well, look, okay, in my opinion, I think X or Y is important, but they can also use standard validated methodologies for assessing the quality of structured academic data and score them. And actually what we then have is a very precisely curated granular analysis of these documents, and we are able to begin to score and assess data that we wouldn't typically be able to do as part of a standard systematic review. And we can do that at scale, and we can do it really, really quickly. So then we know how relevant our document is. We're then able to create an autonomous document summary, and then we're able to characterize that document. What Kendra did is it gave us tremendous speed and efficiency. So we went from doing 1 or 2 documents a day, which is, of course, just unworkable, to being able to very, very quickly start to label these data sets. So within 2 weeks of setting up our workflow, we'd curated just under 1,500 documents. That's over 15 different COVID-related queries in just 2 weeks. So that was 10% of the entire corpus of knowledge based on a small handful of curators answering questions for us in a kind of really controlled way. So we were really excited by this. For us, this was transformative, and we knew we had something that could really get us to where we wanted to be, which was, of course, ultimately living systematic review. So where are we going? Well, I'm really excited to be able to announce to you today that we are now formally opening up this process that we've been developing. So we now have the Curator dashboard and tool, which will be live, and we really would love it if you would join our community. And what we really want to do with this is to transform the process of peer review and to reward scientists, clinicians, and biomedical experts who read a lot of papers by giving back to the community. We will give back to the community by making all of this data completely open. So we're also really excited to be working with Amazon to make sure that all of this information is accessible to the machine learning community who want to do interesting and important things with this data, because ultimately that's what this is really about. So we're going to massively scale this process. We're going to open up our data sets, and then we're going to do the most important bit, which is starting to create living systematic review tools and veracity checking tools and truth and fact checking tools that can be impactful. And now, of course, if this works for COVID-19, it works for all of the other infodemic use cases that we have in healthcare. I'm a cancer surgeon. We have just the same problem in cancer. We've got the same problem in many other different types of infectious diseases and chronic healthcare diseases. And we think this is going to be transformative. And we're really, really excited to be working on it, and also to be working with Amazon as our core partners. And we know that we're just really getting started with Kendra. So with that, I'm going to hand back to Udi, and I would be absolutely delighted to answer any questions you may have. And thank you so much for listening to me today.
Well, James, thank you very much. That was absolutely awesome. For all of you who have joined us today, I just like to say the best way to start with intelligent search is simply to start with intelligent search. Build your proof of concept, compare it to what you have today. Out of the box, we're hearing from our customers that they see some very interesting results. We would love to hear back from you, your feedback, good or bad. We like it both. And we have resources available for you, including solution architects and a lot of information on our website at aws.amazon.com/Kendra. You can find everything from product features and tech talks, recorded webinars, and more. As you've joined AWS Summit this month, in order to learn, we would like to extend the opportunity to learn further with AWS training and certification. There are more than 65 different training sessions for machine learning, so you can expand from here, maybe watch the Kendra one at least a few times. And you can take the AWS Certified Machine Learning exam when you feel you're ready, and continue and explore different opportunities with AWS and machine learning. I'd like to thank you for joining us at AWS Summit this spring. Thanks, James, and thank you, everyone. Moving forward, if you don't mind just filling out the survey about this session. If you enjoyed it, please give us a thumbs up and let us know. If not, we'd like your feedback as well. Very important. Thank you all so much, and have a wonderful spring and summer.